Math 3, Unit 3, Graphing Polynomials. So I'm going to start with going over the different types of polynomials. The first one would be a constant equation. This has x of degree 0 because anything to the 0 power is 1, which means it has no zeros. Remember, zeros are x-intercepts. If we were to graph this equation, it comes in the format y equals c, a constant. It would just be a horizontal line at that constant, which for this one, if you do y equals 7. The domain is always all real numbers. Your range, though, is just whatever your y equals. So your range is just y equals whatever your constant is. And then your end behavior as x goes to infinity, y is just going to equal your constant. And as x goes to negative infinity, again, y equals your constant. A linear equation has one variable of degree 1 and a maximum x-intercept or 0, next number of zeros is 1. It's going to go through the x-axis one time. So this comes in the format of y equals mx plus b. It's going to be a line. Okay, so I'm just going to sketch any kind of line. That would be a positive one. A negative one would go the other way. Notice it goes through the x-axis one time. Your domain is always all real numbers. Remember, this is the same thing as negative infinity to infinity, for those of you that prefer that notation. And your range is going from bottom to top forever, all real numbers. If it's positive, as x goes to infinity, your y is going to go to infinity. And as x goes to negative infinity, your y is going to go to negative infinity. It's going to go up on the right, down on the left. The next one, a quadratic, has at least one x squared, so that is degree 2. And it has a maximum number of 2 zeros, or 2 times it can go through the x-axis. These come in the format of y equals a times x minus h squared plus k, that's vertex form, or y equals a x squared plus bx plus c. A quadratic equation is going to look something like this. Remember, it has that nice U shape of parabola. The domain for all quadratics is all real numbers. The range is dependent upon your vertical shift. So your range here is going to be from your k value, your vertical shift when it's in vertex form, to infinity. Your end behavior, notice as the squared is going in the same direction. So as x goes to infinity, it's going up, y goes to infinity. And as x goes to negative infinity, y is still going to positive infinity. Cubic has at least one x cubed, which means it has 3 x-intercepts. There's not really a good format there. So an x cubed can look like this. It can look just like this. Depends on what else is going on with it. So that one, notice, has 3 x-intercepts. My domain for all cubics is all real numbers. And my range for all cubics is all real numbers. My end behavior is going in opposite directions. So as x goes to infinity, y is getting bigger. But as x goes to negative infinity, it is going down, y is getting smaller. So it's going in opposite directions. Quartic is to the 4th power. So we have a degree of 4 and 4 x-intercepts. A quartic equation can look something like this. It can also be a nice, just a more stretched out parabola. It depends on what else is going on. So notice we have our 4 zeros. My domain is always all real numbers, but my range depends on my lowest y value. And my range has restrictions. It's going to be from a constant to infinity, but it depends on that lowest y value. That has restrictions. Your end behavior, like a quadratic, is going in the same direction. So as x goes to infinity, y goes to infinity. And as x goes to negative infinity, y is still going to infinity. Quintic is to the 5th power, so it's going to have 5 zeros. It's going to look something like this. 1, 2, 3, 4, 5. Kind of like a cubic, just with some more stuff going on in between. It can also look just like a cubic, just way more elongated. My domain is always all real numbers. My range is always all real numbers. And like a cubic and a linear, your end behavior is going in opposite directions. So as x goes to infinity, y is going to infinity. And as x goes to negative infinity, y is going to negative infinity. Your end behavior is dependent on your highest degree and your leading coefficient. So if it's a negative out front, then you're going to switch what you got. Switch the signs of your y's. On the back, we are going to make a nice chart to help you with your end behavior and with sketching potential polynomial equations based on a certain degree and leading coefficient and some zeros. So when you have an even degree with a positive leading coefficient, it's going to look something like this. And your end behavior will be as x goes to infinity, y goes to infinity. And as x goes to negative infinity, y goes to negative infinity. Now, if you have the same function but a negative leading coefficient, that means it's going to do something like this instead. And as x goes to infinity, y is now going to negative infinity because it's going down. As x goes to negative infinity, y is going to negative infinity. An odd degree function is going to look something like this. And your end behavior is going in opposite directions. This is with a positive coefficient. So as x goes to infinity, y is going to infinity. And as x goes to negative infinity, y is going to go to negative infinity. Now, if you have a negative leading coefficient on the same function, it flips it with respect to the x-axis. And it's going to do something like this instead. And that means you're going to flip the sign of your y values here. So as x goes to positive infinity, now y is going to negative infinity. And as x goes to negative infinity, now y is going to positive infinity. So we're going to use this information to sketch some potential polynomials with some given constraints here. So we have odd degree positive leading coefficient. So because it's an odd degree with a positive leading coefficient, my end behavior is going to go down on the left and up on the right. I have these x-intercepts or roots or zeros. I have one at -3, which means I'm going to touch the x-axis at -3, one at 2, and one at 4. Now the difference in touching and crossing, this one's actually going to cross, is the multiplicity. The multiplicity is how many times the zeros happen. So it's the degree of the factor whenever you factor out your polynomial. So here is the x -3. That means that it has x plus 3 to the first power because it happens one time. If it happens more than one time, then that would be an x squared. When it's an odd multiplicity, it is going to cross through the x-axis. If it's an even multiplicity, then it is going to just touch the x-axis. It'll be a maximum or minimum value at that point. So here we have down on the left, up on the right. We're crossing through here. So I'm just going to kind of fill in the blanks. The next one, even degree with a negative leading coefficient, if we look at our chart, is going to go down on both sides. We have x equals -2, multiplicity 1. It's happening one time. If it doesn't say, it's an understood once. We have x equals -4, x equals 1, and x equals 3. We're going down on both sides, and we're crossing through each of these. So now I'm just going to connect the dots here. And these can vary a little bit. This could go down lower, this could go up higher, it could come up, not go down quite as low. It depends on what's going on inside. So it can vary a little bit from mine. The next one, even degree with a positive leading coefficient, means it's going up on both sides. We have x equals -2, but we have that twice. So at -2 there, this means it has a multiplicity of 2, which means it just touches the x-axis. X equals 1 and x equals 5. Those just happen one time, so those are going through. Because of where it's coming from, we are going to touch on that side. So I'm going to Again, this can go higher, this can go lower, but as long as this touches these cross and your end behavior is going well, then you're good. Excuse me. The last one, odd degree with a negative leading coefficient means we're going up on the left, down on the right. We have -1, we have x equals 0, and we have x equals 2, but we have it 3 times. So this is multiplicity 3, which means it is going to cross just like the others. So we're going up on the left, down on the right. It's all going to cross. So it looks something like that, roughly.